Hey guys, so we're just going to continue the lesson from yesterday on point slope form. Point slope form is represented by this equation y minus y1 equals m times x minus x1, where m represents the slope and this y1 and the x1, that is a line that's a point on some line. So line passes through this point. So x1 and y1. So we did a little bit of that yesterday. So in this first example, we're going to write an equation in point slope form of the line that passes through the given point. Oh, sorry, that is not the highlighter. So passing through the points negative 8, 3, and then has this slope of 1/4. So m is going to be equal to 1/4, and our x1, y1 is going to be negative 8, 3. So what we're going to do is take these things and substitute them into the point slope equation. So y minus y1 is equal to m times x minus x1. Okay? So we're going to take this 3, that's my y1. So the 3 is going to go here. The x1 is negative 8, so the negative 8 will go here. And then we have slope. So the slope, we're going to substitute in for m. So after we substitute all of those things, we get y minus 3 is equal to, sorry, not m, is equal to 1/4 times x minus negative 8. So you'll see here that this looks kind of funny. So we have x minus a negative number. So when that happens, we change it to addition. So your point slope equation will be y minus 3 is equal to 1/4 times x plus 8. So that would be your final answer here, because the question specifies to leave it in point slope form, so you don't have to change it to y equals mx plus b. So this next example, we're given the slope and we're given a point, x1, y1. So we're going to do the same thing as we did in the last example. So recopy your equation, y minus y1 is equal to m times x minus x1. And we're going to substitute all these values that we know. So the y is negative 1. So this y is going to be negative 1. The x is 3. So we're going to change that to a 3. And the slope is negative 2. So this is going to be a negative 2. So when we rewrite the equation, we're going to rewrite it with those values. So y minus negative 1 equals negative 2 times x minus 3. And then here you see again, we have these double negatives right here. So subtracting a negative number is the same as adding its opposite. So y plus 1 is equal to negative 2 times x minus 3. So there's really no directions on this one. So this would be one answer if you were asked to leave it in point slope form. If we wanted to change it to slope-intercept form, first you would distribute. So let's recopy this again. And then you're going to distribute the negative 2, so you want to make sure you're watching those signs. So y plus 1, negative 2 times x is negative 2x, negative 2, and negative 3 is positive 6. Then subtract 1 from both sides, and you get y is equal to negative 2x plus 5. So this would be your answer in slope-intercept form. So here we go with number 2. It's very similar to number 1. We're just going to substitute these points into our point-slope equation. So y minus y1 is equal to m times x minus x1. So our slope, negative 2/3, that's going to go there. Our y is 0, so you have a 0 there. And your x is going to be 4. So when you rewrite this, it's y minus 0 equals negative 2/3 times x minus 4. So y minus 0 would be just y. And then if you were to leave it in point-slope form, this would be your answer. So y minus 2/3 times x minus 4 would be your answer for point-slope form. If we wanted to change that to y equals mx plus b, we would have to apply the distributive property. So you would multiply negative 2/3 times x, which is just negative 2/3 x, and then negative 2/3 times negative 4, so multiply negative 2 and negative 4. That will give you positive 8, and then it's over 3. So you have y is equal to negative 2/3 x plus 8/3. This would be your answer in slope-intercept form. So I'm sure you guys can see that this one is a little bit different than numbers 1 and 2 because something is missing. We have 2 points this time, but we're missing the slope. So what we have to do is apply the slope formula. So you're going to want to subtract the y's on top. So remember, your slope is the change in y over the change in x. So you're going to subtract the y values, and you want to make sure you keep the order of subtraction, and then subtract the x values, so those will go on bottom. So 10 minus 4 is equal to 6, 3 minus 1 is equal to 2, and this will simplify to 3. So 3 is going to be our slope. And then we just continue to do what we did before. We substitute all this stuff in to our point-slope equation. So let's do that. It doesn't matter which point you substitute, you should end up with the same equation at the end. So let's specify that we're going to use 1, 4 as our point. So the y is going to be 4. Your slope we already know is 3. The x is going to be 1. So we rewrite this as y minus 4 is equal to 3 times x minus 1. And let's go ahead and distribute the 3x into the parentheses. So y minus 4 is equal to 3x minus 3. Then to isolate the y, add 4 to each side. So y is equal to 3x plus 1, because negative 3 and positive 4 would be 3x plus 1. So there's your equation in slope-intercept form. So now let's do the same thing, just so I can show you guys that it doesn't matter which point you plug in because both points are on the line. So this time I'm going to use the point 310. So your y is going to be 10 this time, x is going to be 3, and the slope is still 3. So we have y minus 10 is equal to 3 times x minus 3. So we distribute in that 3, so 3x minus 9. Then we're going to add 10 to both sides. So y on the left, and then we have 3x plus 1. So it worked out in both cases. So I want to look at number 3 again because there is another way to do this just using y equals mx plus b form, which is slope-intercept form. So we already know from the last slide that our slope was equal to 10 minus 4 over 3 minus 1, which gave us 6 over 2. So our slope was 3. So sometimes you can use this y equals mx plus b form of the equation, and you can get the y-intercept by plugging in your slope and plugging in one of the points. So let me show you what that looks like. So I already know my slope is going to be 3. And then you can plug in values for x and y from the point. So if we use the point 1, 4, we would plug the 1 in here and the 4 here. So when you rewrite it, you have 4 is equal to 3 times 1 plus b. So simplify the 3 times 1. And then you want to isolate b because you want to find what the y-intercept is. So you can subtract 3 from both sides and you get 1 is equal to b, which is the same thing we had in our last equation. So now all we have to do is take this and substitute it back into our slope-intercept form equation. So now we know the b is 1 and we know the slope is 3. So my equation is y equals 3x plus 1. Some people may think that using that form is a little bit shorter, but it's actually the same amount of work. So you get to pick which one you want to do for personal preference. So this last one is a modeling problem. So let's read it together. The student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Tell whether the data can be modeled by a linear equation, and if possible, use an equation to represent the data. So if it's linear, it's going to have a constant rate of change. Constant rate of change. And we have to check for that in the chart. So if you look up at the number of foam hands, we'll call this n, okay? So from 4 to 6, it adds 2. From 6 to 8, it's adding 2. From 8 to 10, it's adding 2. So there's something that's constant happening with the number of foam hands. So let's look at the difference between 34 and 46. So that difference is going to be 12. And then we check to see if that's the same difference from point to point, and it is. So as we found this constant rate of change, we learn that it's $12 for 2 hands. And if it's $12 for 2 hands, that means it's going to be $6 for 1 hand. So it is linear. We can also use the slope formula to double check our constant rate of change. So the number of foam hands is going to be our independent variable. So it's kind of like the x value. And the cost is dependent. So like the y value. Because how many number of foam hands you have is going to determine how much it is. So all we have to do is pick 2 points from the chart. So we can pick 4, 34, and the next one, 6, 46, and then we can find the slope. So I'm going to subtract from right to left so I can have positive values. So 46 minus 34 is my change in y. And so now we're going to do the change in x. So we're going to do 6 minus 4 to keep the order of subtraction. So 46 minus 34 is going to give us 12. 6 minus 4 is 2, and we get the same thing we had up top. So our slope is 6, and that's the same thing as the rate of change. So now that we have the rate of change or slope, we can use our slope formula. Y minus y1 is equal to m times x minus x1 to write an equation for this line since I don't know the y-intercept. So we're going to plug in the things that we know. Let's use the point 4, 34 as our x1, y1. So we have 34 going in for our y1, so y minus 34. We already found out that our slope is 6. And then we have our x1 is going to be 4. So to simplify this, distribute the 6. So y minus 34 is equal to 6x minus 24. And then to get the y by itself, you want to add 34 to both sides. So it looks like it's going to be in y equals mx plus b form. So y is equal to 6x plus 10. So this would be your answer in slope-intercept form. You could have also solved this problem starting with slope-intercept form. So let's do that real quick. So we can also use the same point for 34, where the y value is going to be plugged in for the y, and this x value is going to go in for x, and then we already learned that our slope was 6. So we have 34 is equal to 6 times 4 plus b. So 34 is equal to 24 plus b. To isolate the b, you would subtract 24 from both sides, and that would give us 10 is equal to b, which is the same thing we had over here. So y is equal to 6x plus 10. And if you look in your book, this is an example from your book. The book writes the equation in terms of c and n. So y is really the cost, and x is really the number of hands that you buy, because they're $6 per hand. And then this plus 10. So let me give you a minute to talk to your group about what this equation means as it applies to the context of the problem. So now that you've had a moment to talk to your group, we already know that this is the price per hand. And the y-intercept is like your initial value, which in terms of the context of the problem, this could be something like a setup fee. So it doesn't really say anything about a setup fee, but when you have your equation and you interpret it in terms of the problem, there has to be some kind of setup fee, since there's some custom orders going with the hands. So hope you guys understood the lesson. It was a little bit difficult, but similar to yesterday. I will make sure we go over any questions you have on Monday. So get started on your homework and have a great weekend, guys. See you Monday.